my favorite things ever is dimensional analysis. I know that seems crazy, but I'm serious. It's a way to analyze and solve problems using dimensions, or units. With dimensional analysis, you can figure out how many size 10 shoes lined up end to end it would take to go to the moon, because you totally need to know that, and how many seconds of your life you spend sleeping, or how many formula units of chalk are used to write your name on the chalkboard. It's awesome. Here's the basic idea. Any number multiplied or divided by 1 is still equal to the original number. You could even say that 12 times 3/3 equals 12, and 12 divided by 3/3 equals 12. That's because 3 and 3 are equal to each other, and therefore 3/3 are equivalent to 1. Now take a conversion, like 12 inches equals 1 foot. You could have 2 feet or 24 inches, and that measurement is really the same. They're equal in the same way that 3/3 was equal to 1. So, you can write the equal sign like a division sign and read it, 12 inches per foot. But you could also write it the other way, and it would still be true, 1 foot per 12 inches. This is called a conversion factor, and it's the crux of dimensional analysis. Conversion factors allow you to change from one unit to another, and so on, until you get the units you want. So let's try a problem. How many decades are in 5 centuries? Start with what you're given. Next, in order to get rid of the current unit, centuries, we have to cancel it with the same unit on the bottom of the next conversion factor. Next, you just think of a relationship between centuries and something smaller. In 1 century, there are 100 years. The units of centuries are equivalent, so we can ignore them by crossing them out. Now we need to get rid of years, so put years on the bottom of the next conversion factor, and think of a relationship between years and decades. 10 years makes 1 decade. Years cancel. And all that's left is decades. Now just multiply any number on top and divide any number on the bottom. 5 times 100 times 1 divided by 1 divided by 10. The answer is 50 decades. Now you don't really need to put the ones in your calculator, but make sure the numbers on top are all multiplied and the numbers on the bottom are divided. Let's try another. How many grams are in 750 decigrams? First, you need to know your metric prefixes. I use the mnemonic King Henry died unexpectedly drinking chocolate milk to remember kilo, hecto, deca, unit, deci, centi, and milli. These decrease by a factor of 10 as you go from left to right. Start with what you're given. Now, let the units guide you. Decigram will have to be on the bottom to cancel, and grams will have to go on top. Now give the larger unit a value of 1. And with metrics, see how much smaller the unit is by multiplying. We move from deci to the base unit in one move, so it's just times 10. Now calculate the answer, and you get 75 grams. Let's do one last problem. Convert 7.21 grams per cubic centimeter to kilograms per cubic meter. We're changing 2 things here. First, start with what you're given. When you say per, it's like drawing the fraction line. Now you could choose either grams or centimeters to change next. It doesn't matter, but I'll just go with grams. Grams on the bottom, kilograms on top. Kilograms are larger, so they get a 1. Use the mnemonic to see the amount of difference. Grams to kilograms is a change of 1,000 times. Then grams cancel. Now we can take care of the cubic centimeter and change it to cubic meters. The larger unit, the meter, gets a 1. Now we have to also cube the difference between meters and centimeters, and here's why. On a cube, there are 3 dimensions. That's 1 times 1 times 1, and it gives you 1 square meter. But if we measure the same distance in centimeters, it's 100 times 100 times 100, and so we get 1 million. Or, to save room, you can write 10 to the 6th power. Centimeters cubed cancel, and the only units left are kilograms on top and cubic meters on the bottom, which is what we want. Now, solve. Multiply the top and divide the bottom, and you get 7,210 kilograms per cubic meter. Thanks for watching this episode of Teacher's Pet. Don't forget to like and subscribe and follow me on Twitter @SciencePet.